Heating, ventilation, and air conditioning, or HVAC, is a system that provides comfort cooling and heating to an enclosed space. HVAC controls the indoor temperature, humidity, and purity of air that is sent to different rooms of a building. It replenishes indoor air with fresh oxygen and removes excessive moisture at the rooms. HVAC eliminates air contaminants such as unpleasant smell, smoke, heat, dust, airborne bacteria, carbon dioxide, and unwanted gases. It provides ventilation to replace the air from the rooms, maintains air circulation, and prevents stagnation of air inside the rooms. HVAC using water chiller to supply cool air. This is a typical setup of an HVAC system found in most buildings using chilled water to provide thermal comfort, especially during summer or winter, for the occupants of the building. The building can also contain a data-sensitive room or a laboratory, which needs really clean and comfort air conditioning. In my opinion, I would consider 6 major components comprising the HVAC system, namely the water chiller located at the basement of the building, the air handling unit or AHU, where the fresh outside air is introduced to be filtered and conditioned. Directly connected to the AHU is the ductwork, which sits closer to the AHU, where the filtered conditioned air is distributed throughout the building. The return air duct picks up the heat from the rooms. The air from the rooms is dry and dirty. This air goes to the ventilation, which is part of the AHU. The air is vented or exhausted out of the building. Ventilation is the process of replacing the air from the rooms to replenish oxygen, removes excessive moisture, unpleasant smell, and removes smoke, heat, dust, airborne bacteria, and other unwanted gases from the rooms. Next is the cooling tower, which is normally located at the rooftop of the building. It cools down the warm water from the condenser. Next is the centrifugal pump, located close to the water chiller at the basement. The sixth is the boiler, to provide hot water to the heating coils. And of course, there's a pipe work to connect them all together. HVAC using chilled water to supply clean air to offices. Here is another picture of an HVAC setup in small buildings, also using chilled water. Air contains many pollutants. If you let the air into your home or office without purifying it, your family or the building occupants might end up getting sick. Here in Canada, having 4 different seasons also mean that temperature can go from extreme cold to extreme hot. Having an air conditioning and heating system ensures that you can keep a comfortable temperature in your home or offices no matter what the outside temperature is. So this is the outside air intake. The air goes to the AHU where it is filtered, purified, and cooled. Conditioned air then goes to the ductwork where it is distributed to different offices. The warm, dirty air from the offices is removed and goes into the return air ducting. The air then goes back to the AHU for ventilation outside of the building. A portion of the warm, dirty air is recirculated back to the AHU for filtration and reuse. The cooling tower cools the heat rejected by the condenser. Again, the 6 major components of HVAC are the water chiller located at the basement of the building, the air handling unit or AHU where the fresh outside air is introduced to be filtered and conditioned. Directly connected to the AHU is the ductwork, which sits closer to the AHU and where the filtered, conditioned air is distributed throughout the building. The return air duct picks up the heat from the rooms. The air from the rooms is warm and dry. This air goes to the ventilation, which is part of the AHU. The air is vented or exhausted out of the building. Next is the cooling tower, which is normally located at the rooftop of the building. It cools down the warm water from the condenser. The fifth are the centrifugal pumps located close to the water chiller at the basement. The sixth is the boiler, which provides hot water to the heating coils, and of course there's a pipe work to connect them all together. Now let's look at the first component, the water chiller. I call it the heart of an HVAC. The chiller is an assembly of parts whose responsibility is to produce chilled water or cold water for comfort cooling or air conditioning in the building. The chiller basically is a refrigeration system which houses a compressor, evaporator, expansion valve, and a condenser. You can check out my other video presentation on the basics of refrigeration system and how the components work. Water chiller operation. This is how the water chiller works. First is the compressor. The main function of the compressor is to create a pressure difference between its suction line and discharge line and circulates a refrigerant around the system. An electric motor drives the compressor. The refrigerant leaves the compressor at high pressure, hot vapor. In all our discussion here, we will use the term vapor instead of gas because gas exists only in one physical state, the gas phase, whereas vapor can coexist with another physical state, vapor and liquid, like what is going to happen in this water chiller. At the compressor, the refrigerant vapor is compressed. The volume of refrigerant decreases, but all the molecules are still in there, although they are compacted or compressed. The pressure and temperature of the refrigerant increase, but the quantity is still the same. The refrigerant then enters the condenser at high pressure hot vapor. The refrigerant is carrying the heat from the compressor. The purpose of the condenser is to remove that heat from the hot vapor, thereby turning the vapor refrigerant into liquid. That's the name condenser, which is also a heat exchanger. The hot vapor from the compressor enters the condenser vessel. Cold water at 7 degrees Celsius from the cooling tower goes inside the condenser coils and absorbs the heat from the hot refrigerant. This is known as conduction. The refrigerant, which is outside the tubes, and the water, which is inside the tubes, never mix and are completely isolated inside the vessel. The hot refrigerant then loses its temperature and cools down. As it cools down, the refrigerant begins to condense, turning from hot vapor into warm liquid, still at high pressure. When the cool water absorbs the heat from the refrigerant, it gets warm as it exits the condenser. The warm water at 32 degrees Celsius is then pumped by a centrifugal pump back to the cooling tower. The warm liquid refrigerant exits the condenser at high pressure warm liquid. From the condenser, the warm liquid refrigerant enters the expansion valve at high pressure warm vapor. Expansion valve is also called a metering device. This valve regulates the flow of refrigerant going around the chiller. Its function is mainly to reduce the pressure and temperature of the refrigerant. Because the valve restricts the flow, less refrigerant will flow to the evaporator coils. Thereby, there is more room for the refrigerant to expand. This is called flash vapor. As it expands, the molecules move farther apart. The temperature and pressure of the refrigerant drops. The expansion of the refrigerant gives more ability of that refrigerant to absorb or pick up heat. The refrigerant exits the expansion valve at low pressure cold liquid. At the evaporator, the refrigerant enters at low pressure cold liquid and goes inside the evaporator vessel. Evaporator is also a heat exchanger. The function of the evaporator is to pick up or absorb the heat from the warm water coming from the rooms of the building at 15 degrees Celsius. By the way, the warm water is flowing inside the evaporator tubes, while the refrigerant is outside the tubes. The refrigerant and the warm water never mix and are completely isolated inside the evaporator vessel. It is the cold temperature, low pressure refrigerant that picks up the heat. The refrigerant absorbs the heat from the warm water inside the evaporator coils. The warm water cools down and exits the evaporator as chilled water at 7 degrees Celsius. This chilled water will be pumped towards the cooling coils of the air handling unit. When the refrigerant starts to absorb or picks up heat at the AHU, the refrigerant boils immediately because it has low boiling point. The refrigerant boils and evaporates from liquid to vapor, thus the name evaporator. Refrigerant 134A boils at minus 23 degrees Celsius. It is really low. It doesn't take a lot of energy to boil the refrigerant. The refrigerant exits the evaporator as warm vapor, low pressure. It will then be sucked or drawn by the compressor and the cycle repeats. The warm vapor, low pressure refrigerant will then be compressed back at the compressor. This is a picture of a water chiller. Refrigerant is circulating around this piece of equipment, which houses the compressor suction line from the evaporator, the high pressure discharge going to the condenser, the expansion valve or metering device which controls the amount of refrigerant flowing through the system, and the evaporator which absorbs heat. This is another picture of a water chiller. This houses the compressor suction line, the compressor discharge line, the evaporator, which is insulated with black fiberglass with polyethylene foam underneath. The insulation preserves the temperature of the chilled water at 7 degrees Celsius inside the evaporator tubes. This is because it takes a lot of money to produce chilled water. The condenser is not insulated because this equipment is a heat rejector, which does not need an insulation. Now we come to the second component, which is the air handling unit or AHU. The air handling unit is an integral part of the HVAC system, which takes in outside air and then filters it. The AHU has cooling coils to cool the incoming filtered air to be supplied to the rooms to be conditioned during summer. It also has heating coils to heat the filtered air to be supplied to the rooms that need heating during winter. The AHU adjusts the temperature and humidity of the filtered air and then supplies a comfortable and refreshing conditioned air into the rooms through the ductwork. The dirty air coming from the rooms are sucked and ventilated outside of the building, thus the name ventilation. Some of this dirty air are redirected back to the AHU for refiltering and recirculation. The AHU is normally made of large rectangular metal boxes mounted on the floor and which houses the dampers, cooling coils, heating coils, and blowers. In the HVAC system, the AHU is located between the water chiller and the ductwork, but not in close proximity with the chiller. This is a picture of an AHU which has an entry point for outside air. The air passes through a series of filters and then to the heating and cooling coils. The conditioned air goes to the rooms and picks up heat. From the rooms, the air is drawn back to the AHU as dirty warm air for ventilation outside of the building. The AHU also contains dampers, blowers, and temperature and humidity controllers. This is another picture of an AHU which has an entry point for outside air. The air passes through a series of filters and then to the heating and cooling coils. The conditioned air goes to the rooms and picks up heat. From the rooms, the air is drawn back to the AHU as dirty warm air for ventilation outside of the building. So this is how the air handling unit or AHU works. Outside air is drawn inside the AHU and goes to the damper. This is a picture of a damper. A damper has movable plates that regulate the amount of air going inside the AHU. The air then passes to a panel filter. This is a picture of a panel filter where it captures large particles and debris such as dust, leaves, and even bugs. By capturing bigger particles, the panel filter protects the succeeding filter downstream. Next, the air passes through a bag filter. This is a picture of a bag filter, which is very efficient in capturing very small particles in the air. The filtered air then moves on and passes through the heating coils for heating during winter or for some other heating purposes into the rooms. Inside the heating coils is the hot water supplied from the boiler. If the heater is not used, it is put offline. So this is a picture of the heating coils. The filtered air then passes through the cooling coils for cooling purposes during summer or for other intended cooling purposes into the rooms. The cooling coils are supplied with chilled water from the water chiller. This is a picture of the cooling coils. The AHU has built-in temperature and humidity controls depending on the room specifications. On this presentation, we will use the cooling coils to supply cool and conditioned air and put the heating coils offline. A blower or fan blows the conditioned filtered cool air into the rooms. The warm, dirty air from the room, colored red, is then drawn by an induced fan back to the AHU through the ductwork. The warm, dirty air is vented outside of the building, and some are redirected or recirculated back to the AHU for reuse. This is a picture of the boilers at the basement of the building. This is an electric boiler where water at ambient temperature is heated to 85 degrees Celsius and pumped into the heating coils at the AHU. Next is the ductwork or ducting. Ducts are passages or conduits used to carry and deliver conditioned air from the AHU to the rooms. The cool and conditioned air is blown into the rooms and picks up or absorbs the heat given off by the occupants or equipment inside the rooms. The ductwork carries the warm, dirty air from the rooms back to the AHU. This is a picture of a ductwork which is made out of metal sheets formed either rectangular or circular. Here's another picture of the ductwork which are installed from the AHU and rises up to the ceiling line where they are normally installed. From the ceiling line, it branches out to different rooms. This is a picture of an AHU which is delivering conditioned air into the rooms. Another picture showing the AHU and the ductwork going out for ventilation. Next are the cooling towers. Cooling towers are heat exchangers in which hot water from the condenser is cooled using ambient air. Cold water is collected at the bottom of the tower and is sent back to the condenser at the chiller. The towers are normally located at the building rooftop. Looking at the diagram, warm water at 32 degrees Celsius from the condenser at the chiller is pumped up to the top of the cooling tower. The warm water is sprayed and gets into contact with ambient air. As the water drops, it loses its temperature and cools down. Some of the water is evaporated. Using an induced fan, the air is drawn upwards together with the evaporated water. The evaporation would look like a cloud-like smoke that can be seen on top of the cooling tower. The cool water is collected at the bottom sump of the tower. The cold water exits the condenser at 7 degrees Celsius and is pumped back to the condenser to absorb heat from the hot refrigerant at the water chiller. This is a picture of a cooling tower. Warm water from the condenser enters at the top of the tower. Ambient air gets in contact with the sprayed water using an induced fan. The warm water cools and collected at the bottom of the tower. Another picture of a bunch of cooling towers on large capacity HVAC system. Next are the centrifugal pumps. A centrifugal pump is a mechanical device that transfers cold water from the evaporator to the AHU and also transfers warm water from the condenser to the cooling tower. A centrifugal pump basically consists of a fluid inlet at suction line where the water enters. The impeller rotates and draws the incoming water. An impeller is a rotating steel disc with vanes. It is powered by an electric motor. The impeller transfers energy from the motor to the water by increasing the water velocity radially outwards from the center of rotation. When the motor turns, a centrifugal force is created, causing the water to be drawn towards the impeller. The water is directed around the circular casing. The water is then discharged at the volute. Centrifugal pumps are popular for HVAC usage because of its simple design, high efficiency, smooth flow, low operating costs, and ease of operation and maintenance. The sixth component is the boiler. A boiler is also called a steam generator. It is an apparatus or equipment designed to convert a liquid to vapor. In this case, we will use an electric boiler, which is powered by electricity to produce only hot water, not steam. Hot water coming out of the boiler at 85 degrees Celsius going out into the heating coils. The hot water returns back to the boiler at 75 degrees Celsius. You might ask, why not use a water heater? A water heater mostly provides hot water at only 60 degrees Celsius. We need a higher water temperature for the HVAC system. At the boiler, water at room temperature is heated to 85 degrees Celsius. The hot water exits the boiler and goes to the heating coils at the AHU. Now we come to the last item of this video presentation. And this is how all the 6 major components of the HVAC system work to give you the ultimate in comfort, cooling, and heating. From the water chiller at the basement of the building, chilled water is produced at the evaporator at 7 degrees Celsius. The chilled water is pumped to the air handling unit and enters at the cooling coils. At the AHU, the ambient fresh air, which is now filtered and recirculated air from the rooms, is cooled by the chilled water. The chilled water temperature increases and goes back to the chiller at the evaporator as warm water at 15 degrees Celsius. The warm water goes inside the evaporator tubes and its heat is absorbed by the refrigerant. The warm water and refrigerant don't mix inside the evaporator vessel. The warm water cools down and then exits the evaporators as chilled water. The heat from the warm water is absorbed and carried by the refrigerant at the evaporator. By heat exchange, the refrigerant boils to vapor and goes to the compressor to be compressed into high pressure hot vapor. Moving on, this hot refrigerant vapor enters the condenser and is cooled by the cold water at 7 degrees Celsius from the cooling tower. By heat exchange, the hot vapor refrigerant cools down. The cold water from the cooling tower increases its temperature as it absorbs the heat from the hot refrigerant. The water exits the condenser as warm water at 32 degrees Celsius. The warm water is pumped up to the cooling tower and enters the cooling tower at the top. Ambient air cools the warm water and turns to cold water collected at the tower sump. The cold water from the sump goes back to the condenser at 7 degrees Celsius. At the AHU, ambient fresh air is drawn inside and controlled by a damper. which controls the amount of air. The air is filtered by a panel filter and a bag filter. The air is cooled at the cooling coils, and its temperature and humidity is also controlled. The filtered air goes into the ductwork and branches out to different rooms to provide good quality filtered and conditioned air. The low temperature conditioned air picks up the heat from the occupants and equipment inside the rooms. The dirty, unfiltered air is drawn out of the rooms and goes back to the ductwork. From the network of ducts, the air is channeled back to the AHU and is vented outside of the building. This is called ventilation. Before ventilation, some of the dirty air is diverted back for recirculation to the AHU and to the rooms. When heating to the rooms is required, a boiler provides hot water at 85 degrees Celsius to the heating coils at the AHU and heats up the incoming outside air. By heat exchange, the hot water cools down to 75 degrees Celsius and is pumped back to the boiler. If you think this is helpful information, please subscribe to Engineers Got Talent.